Welcome back to the second part of the endocrine system. In this part, we're going to talk about the hypothalamus and then move on to the posterior lobe of the pituitary gland. So, the hypothalamus is the link between the nervous system and the endocrine system. And so, it's this bright green area right here below the thalamus, a thing that looks like the Easter egg. And the hypothalamus actually has some nervous system functions. It regulates the internal environment through the autonomic nervous system. So it's looking at temperature, it's looking at heart rate, it's looking at salt and water concentrations, and it's going to do a bunch of stuff to regulate that. But it also secretes hormones that can make other endocrine glands secrete hormones. Okay. So there is its link to the endocrine system. So it can do that by controlling secretions of part of the pituitary gland. And if we look, we can see that the pituitary gland is actually connected to the hypothalamus by a little stalk. Okay. And if we look at the pituitary gland, it actually is divided into two lobes. We have an anterior pituitary, an anterior lobe, and a posterior pituitary. And each lobe secretes different hormones. And if we look at them, each lobe looks a little differently. Like if we look posteriorly, we can see yellow neurons going from the hypothalamus to the posterior lobe, and we don't see them going to the anterior lobe. And instead, we see, I don't know, this spongy stuff in the anterior lobe, and that's meant to represent the fact that we've got little glands in there making and secreting hormones in the anterior lobe. So let's look at the posterior pituitary. The posterior pituitary is what we call neurosecretory. In other words, neurons are involved. There are neurons whose cell bodies are up in the hypothalamus and their axon terminals are in the posterior pituitary, and the axons obviously connect the two. So way up here in the cell body, that's where the nucleus is, the Golgi, all that kind of stuff. So up there, hormones are being made and they're being packaged up there in the cell body of the neuron. And then they travel down the axon and they are stored in the posterior pituitary in vesicles. And that's where it hangs out. Okay. So there are two neurons there are two hormones that these neurons make. So in other words, there are two hormones that can be released into the bloodstream from the posterior pituitary. And so we don't say the hormones are coming from the hypothalamus. The hormones are coming from the posterior pituitary. And these two hormones are antidiuretic hormone and oxytocin. So to understand antidiuretic hormone, you need to understand the word diuretic. A diuretic is something that makes you need to pee. So an antidiuretic would do the opposite. Okay, so here is how antidiuretic hormone works. So if you go back and remember, I said like the hypothalamus recognizes salt and water concentration. So up there, it has recognized that you have a high blood salt concentration. Maybe you went to the movies the night before and ate a lot of salty popcorn. Or maybe you had a really salty pizza or salty pretzels at the football game. But for whatever reason, now you have a high blood salt concentration. And that's not good because that's going to raise your blood pressure, and your body doesn't like that. And it's saying, we got to get rid of that high blood salt concentration. And so what's going to happen is that the chemoreceptors up there in the hypothalamus are going, what? No, we can't have this. And so the posterior pituitary is going to be releasing antidiuretic hormone into the bloodstream. And that antidiuretic hormone being released from way up here in your brain is going to travel all the way down to your kidneys. And when it gets to your kidneys, what's going to happen is your kidneys are going to take water that would have been going into your toilet from your urine and send it back into your bloodstream. So now you're only going to have a small volume of very concentrated yellow urine, and the water is going to go back into your bloodstream to make it more dilute. The net result of this is the salt concentration lowers back to normal. Kumbaya. You're back at your set point again. Once you're back at the set point, antidiuretic hormone is no longer being released by the posterior pituitary. This is negative feedback. So let's practice. So here's how you would do that. You're going to put the hormone in the first blank. It's going to be released until the blood level of what? What are you monitoring the blood level? Put that in the second thing. And you're going to monitor that blood level until that reaches the set point. Were we monitoring the blood level of the hormone in this case, or were we monitoring the blood level of something else? Okay, so stop and think. Okay. When the blood level of whatever we are monitoring hits the set point, that's when we're going to be having negative feedback. So now think about, where is negative feedback going to occur? What organ was releasing the hormone? Put that in there and then put what the hormone is. You got any problems with this? Shoot me a message through the Canvas inbox. And now let's look at the second hormone, because remember, posterior pituitary only releases 2 hormones. So we've done one. Second one is oxytocin. You may have heard about oxytocin. Here's how oxytocin works. When a lady is really pregnant and ready to give birth, the baby's head is pushing down on the cervix. When the baby's head pushes on the cervix, the nerve impulses from the cervix get transmitted to the brain, and it stimulates the pituitary gland to secrete oxytocin. And the oxytocin gets carried down to the uterus and causes uterine smooth muscle to contract. When that uterine smooth muscle above contracts, guess what it does? It pushes the baby's head down on the cervix of the uterus, which causes more impulses up to the brain, which causes more oxytocin to be released, which causes more pushing on the cervix, which causes more messages, which causes more oxytocin, which causes more pushing. Can you see? It's going more and more and more. And so you go from having contractions every 10 minutes to every 7 minutes to every 5 minutes to every 3 minutes. And by every 3 minutes, you need to go to the hospital. And then in transition, you're going to have contractions every 2 minutes. And at every 2 minutes, lady, that means you are having a 90-second contraction, followed by a 30-second relaxation, and then another 90-second contraction. And you are pushing, followed by a 30-second relaxation. Awesome, you're going to have a baby. Yay! Once the baby comes out, there's no more head pushing on the cervix. All right, there's a little bit of oxytocin still left in your blood, so you'll usually have 1 more contraction, maybe 2 more, enough to get rid of the placenta to come out. And then there's nothing left. There's no, that's it. But hey, we can get oxytocin one other way, ladies, and that is when the baby is suckling. When the baby suckles, what happens is there are smooth muscle cells that surround where the duct, where the alveolus is filled, where part of the breast is filled with milk. It is surrounded by smooth muscle cells. And so when the baby suckles, oxytocin comes down and makes this smooth muscle contract. And so we have what's called the milk ejection. You're not creating milk, you're not producing it, you are ejecting milk, which was already created by a different hormone. All right. And so this happens. So yes, can that make your uterus contract and give you a cramp, like a menstrual cramp at the same time? Absolutely. Only nobody ever tells you that on your first baby. Yes, I know. And then ladies, your body will be so fine-tuned that later on what will happen, much to your dismay, your baby crying is enough for you to have this milk let down, milk ejection to come out in public. Just hearing the baby cry, you will start leaking. Not a good thing. All right. So this obviously was not negative feedback. This was positive feedback, just like what happens as temperature is warming and the sea ice melts and shrinks. And sea ice shrinks, then more temperatures warm, and more shrinks and more warms. And so what happens with global warming creates more changes, which speeds up global warming. This is positive feedback. The stimulus is bringing an effect that increases the change. This is not negative feedback. I can't tell you how often I get students that write me and they go, I'm having difficulty doing a negative feedback loop for oxytocin because it's not negative feedback. Okay. If the event ends due to an external event, such as giving birth, or the baby stops suckling because its stomach is full, that's your clue. It's positive feedback. You are not maintaining homeostasis. You are going out of homeostasis. Positive feedback controls the release of oxytocin. Please do not do a negative feedback loop for oxytocin. That's it for this section. I'll see you for the third one when we come back and we talk about hormones from the anterior pituitary, where there's quite a few more than just two. See you soon. Thank you for all your hard work.